Welcome to the Deep Dive. Today, we're taking off into the world of commercial aircraft wings.
That's right.
We've got a recent market research report here that gives a really fascinating look at, where things stand now and where they're headed. It's a vital part of aviation.
Exactly. We're going to explore the key trends, some of the really interesting tech advancements happening, and also touch on the challenges manufacturers are, well, grappling with.
Right. The idea is for you, the listener, to get a solid grasp of what's shaping these structures that, literally keep planes in the air.
And the growth forecast is pretty significant.
It really is. The report sees the market climbing from about $41.2 billion this year, 2024, to over $76.3 billion by 2032.
Wow.
Yeah, that's an 8.0% compound annual growth rate. So let's get into what's really powering this.
Okay, let's start with the current market situation. What's fueling things right now? It's really a mix of factors. We're seeing a big jump in demand for more fuel-efficient aircraft, and that's not just about, more people flying.
No, there's pressure, right? Fuel costs, emissions.
Exactly. Volatile fuel prices, growing pressure on emissions, it makes efficiency absolutely top priority for airlines.
Makes total sense. Wings aren't just structural. They're crucial for aerodynamics, fuel burn, performance.
Fundamentally.
And this report highlights a real shift towards next-gen designs. Things like folding wingtips, which are pretty clever, actually.
Yeah, for gate space.
Right. And a much bigger focus on using lightweight composite materials.
And what's interesting is how connected these things are. The push to cut emissions, fly further, carry more, it all points towards lighter, more advanced wings.
So it all ties together.
It does. The analysis from Cognitive Market Research really nails this down, saying increased aircraft production and these material and design innovations are the main growth engines.
And that jump from $41.2 billion to nearly double that by 2032 really underscores the momentum.
Absolutely.
We're also seeing more adoption of, well, seriously advanced stuff. Carbon fiber reinforced polymers, CFRP, and even smart wing tech. That sounds almost sci-fi.
It does, doesn't it? But it's becoming more real. These smart wings, they basically have sensors, actuators. They can subtly change shape during flight.
To optimize performance.
Exactly. Optimize it in real time based on conditions. And the report mentions a manufacturer last year introduced a composite wing cutting aircraft weight by 20%.
20%? That's huge.
It is. And that directly means better fuel efficiency, lower emissions, a massive advantage.
So looking ahead then, what are the big trends shaping the sort of near-term future?
Well, connecting to that, a key trend is definitely adopting these advanced wing technologies more widely. The report mentions adaptive and morphing wings.
Wings that change shape in flight.
Yeah, imagine that. The potential to optimize lift and drag constantly throughout a flight.
That's wild, like bird wings almost, but on a massive scale. So how far off is that really? Are these just prototypes? What are the hurdles?
Good question. The basic ideas are there, but putting them on commercial jets, that's tough. You've got complex mechanisms, reliability over thousands of flight hours, and, the safety certifications.
Right, the red tape.
It's more than red tape. It's essential safety assurance. We're seeing progress in research, some experimental use, but it'll likely be a gradual thing for mainstream fleets.
Okay, makes sense. Can't rush that.
Not at all. Then there's the big push for sustainable aviation. It's intensifying. Regulations on carbon emissions are really speeding up that shift to lightweight composites we talked about.
Because they're lighter but still strong.
Exactly. Better strength-to-weight ratios.
And it sounds like the market's generally healthy. Strong order books, fleet upgrades.
Very much so. The report notes strong backlogs, airlines modernizing their fleets, plus the growth of low-cost carriers needing more planes, all supporting expansion.
Okay. And regionally, where's the action concentrated?
Right. The regional breakdown for 2024 shows North America leading with about 38%.
Which makes sense with the big manufacturers there, lots of R&D.
Precisely. High R&D investment, high production rates. Europe's close behind at 30%. Also a strong aerospace hub, innovating in aerodynamics, composites.
And Asia-Pacific.
Asia-Pacific has 25%, but it's seen as having huge growth potential. Air travel is expanding rapidly there, more planes being bought, governments investing.
Interesting. So with all this growth, what are the manufacturers themselves focusing on? Just building more?
It's more than volume. They're really pushing production efficiency, trying to lower maintenance costs down the line, and of course, developing those next-gen aircraft architectures.
And the big names we know, Boeing, Airbus, Bombardier, They're still dominating.
Oh, yeah. Boeing had over 40% market share in 2024, Airbus around 30%, Bombardier about 15%. They've really cemented their place through, well, constant innovation.
Right. Better aerodynamics, lighter materials, better fuel burn.
That's a relentless cycle, and it's
Yeah.
all driven by that rising demand, more travel, fleet upgrades, and that huge emphasis now on sustainability.
The report really flags the investment in composite wings. Said something like 55% of new commercial aircraft wings in 2024 were composites.
That's right, about 55%. It's a major shift from traditional aluminum alloys.
So why the shift? What's the technical term? Aerostructural efficiency.
Aerostructural efficiency, exactly. It means the wing is great at generating lift and minimizing drag, but also structurally sound, all while being as light as possible.
Got it.
Think of the Boeing 787 Dreamliner, the Airbus A350. Their composite wings are a huge reason they get that 20–25% better fuel efficiency.
Impressive numbers.
Definitely. And Bombardier is doing crucial work too, focusing on those lighter, high aspect ratio wings, especially for regional and business jets. Different market segments drive different types of innovation.
Okay, so let's dig a bit deeper into the tech itself. We've mentioned composites and morphing wings. What else is key?
Well, it keeps coming back to aerodynamics, fuel efficiency, sustainability. That's the mantra. Morphing wings, while complex, are still a major goal for optimizing that lift to drag. But even established tech, like winglets and raked wingtips, they're standard now for a reason.
They really do make a difference in cutting drag and extending range, don't they? Those little upturned bits.
They absolutely do. Seemingly small, but the cumulative fuel saving across a fleet is massive.
And the big players are pushing even further. Boeing's got this. Transonic truss-braced wing. TTBW.
Yeah, the TTPW, it looks quite different. It's a concept aiming for ultra-efficient aerodynamics, potentially much longer range, a real potential game changer.
Sounds like it. And Airbus.
Airbus has its Wing of Tomorrow program, also focused on next-gen composites, but also heavily on automating the manufacturing. They're even exploring digital twins.
Digital twins.
Yeah.
Like a virtual copy.
Exactly, a virtual replica of the wing and the manufacturing process. Lets them simulate, optimize, find problems before they even build anything physically. Much more efficient, much more precise.
Wow. Technology is really changing how these things are made.
Fundamentally. And Bombardier keeps advancing too, with those thinner, high aspect ratio wings. Innovation isn't just the big guys.
And geographically. Still mostly North America and Europe building these.
For now, yes, they're the main hubs. But Asia-Pacific is definitely emerging. China, India, they're investing heavily in building their own capabilities.
It's like Comac in China.
Exactly. Comac developing their own narrow-body and wide-body jets signals a real shift. More competition globally could spur even faster innovation.
Makes sense.
But ultimately, it all comes back to sustainability and efficiency. That's what's driving the investment in new designs, lighter materials, digital manufacturing.
So zooming in on aerodynamics specifically, what are the key design advances helping the market grow?
Well, the growth here links back to that demand for fuel efficiency, more air travel, and just better technology becoming available. Manufacturers are laser-focused on designs that cut through the air with less resistance. Less resistance means less fuel burned. Simple as that.
And it's not always brand new wing shapes, right? It's also using these advanced materials composites, better alloys, to make existing designs lighter and tougher.
Correct. Refining designs is just as important. Airlines feel the pressure on operating costs and emissions, so any tech that helps there gets strong interest. That's a huge driver.
And we see things like winglets everywhere now. What about laminar flow wings? Is that becoming more common?
Laminar flow, keeping the air flowing smoothly over the wing, is definitely gaining traction. It's technically challenging, but the payoff in reduced drag is significant.
So even small refinements add up.
They really do over the life of a plane. And like we mentioned, smart materials, morphing concepts, they're slowly moving from the lab towards potential application, allowing wings to adapt dynamically.
And this is all helped by the demand for planes that can fly further more efficiently.
Absolutely. Long-range, ultra-efficient jets are really sought after. So Boeing, Airbus, they're constantly investing in R&D, tweaking designs to optimize that lift-to-drag ratio, extend range, maybe even improve passenger comfort through smoother flight.
And with air traffic expected to keep rising over the next decade.
The need for these advanced designs only gets more critical. It's a continuous improvement cycle.
Okay, so there's a lot of positive momentum, exciting tech, but it can't all be smooth sailing. Are there significant challenges, headwinds facing this market?
Oh, definitely. Despite the positive outlook, there are real hurdles. A big one is cost. Manufacturing these advanced wings, especially with composites and complex processes, it's expensive. It needs specialized skills, high precision equipment.
Right. Cutting edge usually means costly, at least at first. What else?
Regulation is always a factor. The FAA, EASA, other authorities, they have incredibly strict safety and performance rules. Getting a new wing design certified is a long, rigorous process.
Which can mean delays.
It can mean significant delays and added cost in development and getting these innovations to market. You have to prove exhaustively that it's safe.
As you should, of course.
Absolutely. And then there's the challenge of just integrating new wing tech onto existing aircraft designs. It's not always plug and play.
You have to make sure it works with everything else.
Exactly. Ensure compatibility with all the systems, maintain structural integrity. It's complex engineering.
So it sounds like a constant balancing act. Pushing innovation versus keeping things cost-effective and practical for airlines.
That's a perfect way to put it. Finding that balance is key for the market's long-term health.
So looking further out now, what truly transformative developments might we see down the road? Where could aircraft wings go next?
Well, the future looks really dynamic, driven by tech and that sustainability imperative. The report points to something particularly interesting. The U.S. Air Force investing in Jet Zero's blended wing body prototype. That was announced back in August 2023.
Blended wing body.
No.
Okay, let's unpack that. That's where the wing and the body sort of merge into one shape.
Basically, yes. The traditional tube and wing distinction blurs or disappears. The entire aircraft body is designed to generate lift. It's a pretty radical departure.
And the goal there is
Significant cuts in fuel consumption and emissions. By creating a much more aerodynamically efficient overall shape, you maximize lift from the whole structure. It's a fundamental rethink.
wow, that sounds like a huge leap for sustainability.
Hmm.
The report mentioned big fuel savings, maybe even more passenger capacity.
But the potential is enormous. It could really be a game changer. And it lines up perfectly with the whole industry pushing for greener aviation tech.
Makes sense.
And the report stresses that making these radical designs work relies heavily on continued advances in lightweight composites and also additive manufacturing, things like 3D printing.
To build these complex shapes efficiently.
Exactly.
Yeah.
That's key to bringing down emissions and operating costs for these future designs.
So we might actually see planes that look totally different from what we're used to. Not just the wings, but the whole aircraft changing.
That's the expectation, yes. If these blended wing body structures prove successful and are adopted, it could genuinely reshape commercial aviation, making flying much more efficient, much more environmentally responsible, and maybe even more economical long term.
Well, this has been a really fascinating deep dive into the commercial aircraft wing market.
Yeah.
We've covered a lot of ground from what's driving growth now to composites, smart wings,
Yeah.
to the huge potential of concepts like blended wing bodies.
Yeah.
Yeah, the potential for growth driven by that need for fuel efficiency, sustainability, and just pure technological progress, it's clearly there.
Definitely undeniable. And yeah, there are challenges, cost, regulation, integration.
Sure.
But the progress seems relentless. And ideas like Jet Zero's prototype offer a really compelling glimpse into a potentially very different future for air travel.
That actually brings up a final thought, maybe for you, our listener, to ponder.
Mhm.
Thinking about these rapid advances, especially radical designs like blended wing bodies, how might your own future air travel experiences actually change? What kinds of unforeseen opportunities or maybe even new challenges could come from such a fundamental shift in aircraft design? It's certainly something to think about as we look towards the skies of tomorrow.